Hello. So in this video, I'm going to compare the mean and the median. So let me ask you a question, simple question first. In 1986, the University of North Carolina surveyed the starting annual salary of its graduate class of uh, 1984. And it calculated the average salary by major. And then guess which major had the highest average salary, starting salary? Computer science, business, geography, biology, economics. Which one had the highest average salary? Okay, of course, you don't need to know the answer. Uh, the answer is geography. So, actually, the average salary of geography was out, quite, like, high. Why? So national average was at that time was about 22,000, but geography average was 250,000, more than 10 times larger than the national average of college graduates. College graduates starting salary. What's going on? Why the geography earns that much money? That's because it's not because of the geography, but it's because of average. The answer is this guy, Michael Jordan. So Michael Jordan graduated from North UNC in 1984, and he earned, I don't know how much he made in his first year, but he dragged all the average up to this level. So maybe I guess the geography major average, average should be close to this level. Not much different, I guess, right? But because of Michael Jordan, uh, the average is too much inflated. This is the problem of average. So the mean has a lot of advantages. Like it is widely used, so no one asks why you are using the mean. If you use the mean, so people will just accept it, and it is easy to compute. You know how to use it, and you know how to compute it, and almost all programs include the averaging function, and has many nice properties mathematically, statistically. Uh, but it's one of its biggest problem is outliers. When there is an outlier, the mean is affected too much, contaminated too much by a small number of outliers. On the other hand, the median is more robust against outliers, less sensitive. Even if there are a few outliers, still it's okay. Median will be stable. However, everything else, median is not that convenient, like in practice. Like calculate not actually when the number of data is large, it's not easy to calculate the median. Actually, in our previous example, I said it is easy. Yes, it is easy when you can rearrange it easily, but when the number of sample is large, then it's not easy to calculate that. And some people may not be able to understand what is the median. Uh, so, uh, so median is more like a complement to the mean. So your first choice should be the mean, and then if you expect some kind of problem, then as a supplement, the median can be used. But rarely median is used over the mean, right? Let me I like so. For example, outlier suppose that you survey like 10,000 households, and suppose that the mean household income is 0.1 million. It's a similar example as Michael Jordan. But your 10,000 and first survey respondent was Bill Gates. Like these days, like Elon Musk or Jeff Bezos, whatever, any super rich. So if you happen to include super rich into your survey, then we know his income was 12 billion, which is about 10,000 times of the average household. And then if you recalculate the income, including Bill Gates, you get 1.33 million. So just alone, Bill Gates alone increases the mean by more than 10 times. But he's only one observation out of 10,000. So this is the problem. Even a super small outlier, super small fraction of outliers can contaminate the average too much. That is, it is an extreme example, but you see the point. It also happens in our state distribution. California is an outlier. You may think Texas is also an outlier. By the way, there is no academic definition of outliers. How much are outliers? Like New York, Florida, are they outliers? There is no scientific answer to that, but just intuitively, just clearly, California and Texas are outliers. And then we are going to do a simple experiment. So if you use 51 states including DC, the mean was 6 and the median was 4.3. Now, I'm going to drop only one observation. So one observation affects the mean by 0.62, which is about 10% of the mean. So the drop in the mean is more than 10%, but the median drops only by 0.25. So remember, there are 50 states, and we are comparing what happens when you add and drop California. The change in the mean is more than 10%, but median change is less than, like, say, 5%. About 5%. So you can see that median is more stable, right? It changes from 4.3 to about 4.1, right? Now, additionally, if you drop Texas, then the mean falls again by 0.4 by Texas, but median drops by 0.24. So when you add or subtract the outlier, median changes little, but mean changes much more. So mean is more sensitive, but median is more stable. This is the difference between the mean and the median with respect to outliers. This is actually a bigger problem, quite a big problem. And from the histogram, it is easy to tell where is the outliers. Outliers are these guys. Usually we call them tails. Like a histogram is usual, but there is a long tail, then that's outliers. In this case, outliers are on the left side, left tail. So then in this case, if you calculate the mean and the median, mean must be smaller than the median because these outliers will drag down the mean more than the median. Even if the mean and median was the same, the outliers make mean much smaller than the median, right? Similarly, if outliers are on the right side, that is, they are on the larger side, extremely large observations, then they will make the mean much larger than the median, right? They increase the mean much more than they increase the median. So outliers are on both sides. This is particularly important in economic data because, like in our nature, outliers are quite rare. Like for example, you never see a person like 60 feet tall, like 10 times taller than me, does not exist. Or in a factory, like if a smartphone is manufactured, there is no error. It may have a small manufacturing error by like millimeters, but you never see like smartphones twice larger than what it had to be. What it like so more natural errors do not have outliers. But in economics, outliers are common, especially in social sciences. Um, Outliers are common. Like, for example, as I said, Elon Musk, Bill Gates, Jeff Bezos, Warren Buffett, the super rich guys are not only 10 times richer than me, they are like, I don't know, like 1,000, 10,000, 100,000 times richer than me. And like giant firms like Apple, Microsoft, Google, Amazon, these companies are quite different from on average usual companies. So it's different. And stock market, when it crashes, it crashes a lot, right? Uh, so there are extreme cases. Extreme cases are more often in economics, in economic data, compared to like natural sciences or more engineering data, right? So that's a big problem. So here is an example. When we usually say the economic growth, we usually use the average income. Average income is the like GDP per capita. GDP per capita is the total sum of GDP divided by number of population. So that's like average income per person. So this is average income, which has grown quite like continuously from 1975 to like 2009. So the United States like economic growth pretty well in terms of average. However, look at the median. Median household income shows totally different result. The median is not increasing that much. It's quite like it increased, but not as much as the average. What does it mean? It means that increase in the average is like kind of inflated by outliers. So super rich becomes much more rich, much richer than the median household. Median household increased a little, but relative to the median, the super rich guy, extreme outliers, have increased much, much more. So that is that's what this graph tells you. It's surprising, right? So, like you see the importance. Average can be misleading. Like just looking at average is good. Like I'm not saying it is bad, but you have to understand its potential problem. Potentially, it can be misleading. So even if that's the first choice, almost in any case, but when you use the average, also make sure if there is any outliers or if median can be different from the average. So if you understand their difference, you may do a better analysis. You can look at the data from different angles. So it will be much more comprehensive analysis. Okay, so this is the end of the comparison between mean and median. So in the next video, maybe the last video, will be another about another topic, another set of measures, which is less important than what I have explained so far. Okay, then see you in the next video. Bye.